Hello, this is Ms. Schultz. So I'm going to do two examples in this video on separable differential equations. These are the first two examples I teach, so they're fairly like intro level. So the first thing you want to do, so we have dy dx, so you're given a derivative equals 4x over y, and you have this, which is called an initial condition. Initial condition. This is the x value, this is the y value, just to annotate, and then find an equation for y. So how we're going to do this is we're going to separate the variables. That's our first step. So we're going to get all the y's on the left and all the x's on the right. So right now I see a dx on the left. I can actually separate this dy dx. They don't have to stay together by multiplying by dx on both sides. So dy equals 4x over y dx. Okay, and then I still have y on the right, so I'm going to multiply by y on both sides. And I get y dy equals 4x dx. Okay, so that's step one, separating variables. Okay, step two is I'm going to integrate both sides. Why? Because I have a derivative and I want to find an equation. I have dy dx and I want to find an equation for y, so that's an antiderivative or an integral. So I'm going to integrate y dy, and I'm going to integrate 4x dx. So when I integrate, the integral of y dy is y squared over 2 or a half y squared, either way. The integral of 4x is 2x squared. Now I can put a plus c here and a plus c there, like a c1 and a c2, for example, and then I can combine them. We talked about this in class. So I really only need a plus c on one side. So that's the integration step. Now, step three is to solve for plus c. So I'm going to use my initial condition. So use the initial condition. Think about how I can use this x value and this y value of the initial condition to solve for the plus c. If you thought substitute in, that's right. So I'm going to substitute 5 for my y, 1/2 5 squared. I'm going to substitute 0 for my x. So I get 25 halves equals c. Oops, excuse me. 25 halves equals c. I'm just writing these lines to separate out the steps. So now I'm going to substitute my c back in. Right before you substitute in the initial condition, that's the version that I'd like you to use to put the c back in. So 1/2 y squared equals 2x squared plus 25 halves. That's why it's like not that great. So that's me substituting the c back in. And then last step, I'm going to solve for y. So for me, I'm going to multiply everything by 2. Y squared equals 4x squared plus 25. I'm going to keep solving for y. I'll go all the way over here. So I take the square root of both sides. When I take the square root, I need to add the plus or minus. So y equals plus or minus the square root of 4x squared plus 25. You cannot simplify this. Think of this as an exponent of a half. Exponents do not distribute over addition. Multiplication does, but this is not multiplication, so you can't simplify it. Now this plus or minus, you actually need to, I'm not done yet, even though y is solved for. I need to actually choose between the plus and the minus. It's not going to be either one. So is my y value, let's think, positive or negative? Let's look at my initial condition. Is the y value positive or negative? Well, it's positive because it's 5, positive 5. It tells me. So I'm going to choose the positive case because I have the 0.05, which is positive. And so the final answer is y equals root 4x squared plus 25. That is my equation for y. Okay, so that's example 1. Let's move on to example 2 with separable differential equations. Okay, so this is pretty similar, just like there's a little bit of a fraction mix up. Okay, so I'm going to multiply. So step 1 is to separate the variables. I'm going to list the steps on this side. So 1 is separate variables, or we'll just write separate vars to jog our memory. Okay. So I'm going to multiply by dx on both sides. Sometimes you'll be able to do, I'm going to take 2 steps to do this. In the future, you might be able to do it in 1 step, 3x over 2y dx. Okay, so this y, I'm going to move to the other side. You can move the 2 along with it or not. It doesn't matter. So you can multiply by y on both sides, or you can multiply by 2y on both sides. I find most students multiply by 2y on both sides because this is a term together. And that will eliminate my fractions. I love clearing fractions. So I'm going to multiply by 2y. 2y dy equals 3x dx. So that is my separate variable step done. Step 2 would be to integrate. Okay, so I'm going to integrate 2y dy and 3x dx. Okay, just the indefinite integrals. The integral of 2y is y squared. I don't need a plus c on both sides. I'll just put it on the right. The integral of 3x is 3 over 2 x squared. And then I'm going to do the plus c. So that's my integration step. Step 3 is solve for the c by using my initial condition. So here's my initial condition. X is 0, y is negative 10. I like annotating x and y. So negative 10 squared. Make sure you substitute in parentheses because that'll make a difference here. Because a negative 10 squared is positive 100. So 100 equals c. So I've now solved for the plus c. Okay, let's keep going. So step 4 is to sub c back in. Sub in the c. All right, so here is where, right before I substitute in, that's what I'm going to substitute in for. Y equals 3 halves x squared plus 100. And then I'm going to solve for y. So how do I get y alone? It's y squared, so I'm going to square root both sides. When I square root, I have to add a plus or minus. Okay. And then let's think, is this the plus or the minus and y? It's the minus because the y value here is negative. The y is negative 10. So y equals negative root 3 halves x squared plus 100. Okay, so those are 2 pretty similar examples. All right, thanks for watching. There is another video up too with this example is on another video. And then my last example on the next video is with this bamboo problem. Okay, thanks for listening. Bye.